DigiComp 2 can add, subtract, multiply, and divide binary numbers using small Lego balls to activate gates. These gates, or flip-flops, are essentially bits and are grouped into two registers: the MQ, or Q register, on the far left with 3 red gates, and the accumulator, or A, on the right with 7 gates, most of which are out of view in this video. In between is a bank of red switches that serves as the 4-bit memory register. The registers are read from bottom to top, least significant bit at the top. To multiply, balls are fed into the distributor, the 3 blue gates in the upper left, to be distributed to each bit of the M register, adding those bits with carries to whatever is already in the accumulator. One of these 4 balls also subtracts 1 from the Q register, until finally one ball falls out or underflows the register, ending the computation. Here you can see that the 2 and 4 bits are set in the accumulator, representing 6. Multiplication is done by repeated addition. Since the accumulator can hold 7 bits, results up to 127 can be represented. Here you can see the entire device and can see how each falling ball triggers the next one at the yellow trigger pad at the bottom. Here the accumulator has the highest and lowest bit set, signifying 65, and the last ball underflows the Q register to stop the calculation. Subtraction can also be accomplished by performing what is known as the 2's complement to the value in the accumulator before adding another number to it. This is also automated using the gray mode switches just to the right of the accumulator and a set of switches and flip-flops at the top and bottom. After complementing the accumulator, the white multiply switch is set at the top and the computation is restarted, now multiplying the Q and M registers together and adding the result to the accumulator. Finally, the result, 6, is stored in the accumulator, and the Q register underflows to stop the calculation. Using the very light Lego soccer balls presented some challenges. Getting a 2-gram ball to reliably trigger the next from a distance of more than a meter required 2 delicate mechanisms connected by a thin string. A very reliable gate design was also critical. A simple problem like 2 times 7 involves 9 balls cascading past at least 83 gates or switches, so 99% reliability is almost a must. A gate must flip when the light ball hits it, but must not accidentally flip due to the vibration of the calculation. In addition, some gates are one-sided, and more than half the gates are dual-layered, complicating the design.